Okay, folks. Hello. Happy snow day on Thursday. I hope you enjoyed your time off. We are going to go ahead and do a video follow-up for Chain Rule 3.8, and we're going to expand it into a couple more problems here. All right, so you've got all your notes. Let's just go ahead and title it 3.8, More Chain Rule. And with our examples today, we're going to go ahead and look at our little flow chart here. And of course, reorganized it a little bit because now we have this thing called chain rule. Notice that these two boxes here, those are still the things that you think about first, okay? And then if this U substitution results in the power rule, then you get the chain rule. All right. Let's go ahead, and I'm going to rewrite the definition here. F composed of G, and that means that the derivative is F prime copy times G prime. And I'm going to highlight the part that we're copying, and I'm going to underline the derivative that's connected to it. Sometimes we use this in terms of U substitution to figure out where the two functions are. Okay, so for example, you could say f of x equals 3x to the fourth, and we can say g of x equals 3x minus x squared. And then the composition is where you substitute. Okay. This piece here is going to go into this part. In order for chain rule to work, okay, this is composing. We have to decompose. We have to separate them back into their original pieces. Notice that f of x all by itself is just a power rule. Notice g of x all by itself is just a power rule. And that's what I'm looking for. Rewrite into power format. If you have to decompose with that substitution, then we're going to get the chain rule formula. And so I'm going to highlight what appears to be the inside function right there. And if I can kind of blur that part out, I see 3 blur to the fourth, which is a power rule. And then I look at the highlighted portion, 3x minus x squared, and that is just a power rule. So let's do the example. We're going to go ahead and start with this part right here. And I know that some people really prefer the format, and so I'm going to rewrite this with f and g. F and g are kind of tricky. Okay, f of x equals 3u to the fourth. I like u because I don't really want to reuse x. I just don't. Okay, so u of x equals 3x minus x squared. Power rule, power rule. Do the derivative. Okay, so I'm going to change that because this letter should match this one. So let's do the outside derivative. F prime of u equals 12u cubed. U prime of x equals 3 minus 2x. Now the reason I didn't use x's here is because I don't want to forget that your final answer must have all x's, which means you've got to replace back that u. Okay, the chain rule says outside derivative times the inside derivative. So y prime equals 12 bloop, cubed times, use your parentheses, and substitute your u back in. All right, now let's look at it, because I think chain rule is one of those things where the notation actually makes it a little bit harder than it needs to be. And so I am hoping that we can get from this step to this step by using that highlighter to help separate the pieces. Outside derivative, okay, copy, derivative of the thing you copied. Let's do it again. Y equals negative 4 plus x cubed to the negative 2 power. Okay, highlight the part, okay, simplify. Don't think I can do that. First, rewrite into power format. Seems to already be in power format. Does u substitution work? Yeah, if I can highlight this inside function, and when I separate them, okay, f equals negative 4 u to the negative 2. That is just the power rule. Okay, I'm going to leave my parentheses. I think it helps. Okay, u equals 4 plus x cubed. That is just the power rule. Okay, f prime equals 8 u subtract 1 u prime equals 3x squared. Okay, put it together. Outside derivative times inside derivative. We're multiplying these two things together. Y prime equals 8 bloop times. All right, so I've got to do the copy part. I'm going to highlight it, and as I'm looking at it, my hope is that you will eventually be able to go from that first line to the answer without actually writing that u substitution out. Okay, but this is a negative exponent, and we're not going to leave our answer with a negative exponent. So as I'm looking at these things, those two pieces aren't going to move. That's going to give me 24x squared. And this is going to give me the whole grouping is going to move down to the denominator. Answer. Now that was a little bit of review from our first lesson. Okay, notice that we haven't made it outside of our power rule bubble. All we did is we added this part here where we multiply these two derivatives together, but we continue with copying that inside piece. We're going to expand and use some of these other rules as we incorporate the chain rule. All right, let's look. How creative can we get? Y equals 3 over plus 4 cubed. Okay, let's go through our little chart here. Can you simplify this? No, there's no reducing. I can't actually do the division because the 3 has a smaller power than the cube. Can we rewrite this in the power format? It kind of appears that the numerator right? Power format. The numerator is in power format and the denominator is in power format, okay? If I use U substitution, will I have power format? And I want to ask you something. Quotient rule only applies if it's a big one. Okay, quotient rule only applies if both top and bottom have a non-zero derivative. Okay, non-zero derivative. That's kind of a big thing here. Non-zero derivative. Because I look at the 3 here, and the derivative of 3 is 0. So this doesn't necessarily have to be the quotient rule. Now to show you, I'm going to do it 2 ways. Top is 3. Derivative of the top is 0. Oh, bottom, okay, is x plus 4 cubed. Oh, derivative of the bottom. Okay, this is where it gets kind of fancy, guys. What's the derivative of the bottom? Now, see this? See this? This brings us back here. Every time you're trying to do the derivative of a piece, you come back to the beginning. It's in power format. The U substitution will work. 3 copy squared times 1. Cool. And I'm just going to sort of move those 3 and those 1s together here. All right. Let's do the quotient rule. The derivative is the bottom derivative the top minus the top times the derivative of the bottom. All over. Ugh, okay. The bottom squared, which is actually a 6 power. Now, blip. Right, that's a 0. Okay, so let's figure out what we have. Minus 9 x plus 4 squared. Okay, you're going to have to reduce this, all right? And so these 2 cancel out, and you're only left with 4 on the bottom. Okay, equals negative 9 x plus 4 power 4. Not so bad, right? Chain rule just appeared within the derivative of the top or the derivative of the bottom, which is just like the problems that we practiced. Okay, what if I can make the chain rule happen? Because as I'm looking at this, I see that 3 has a derivative of 0. And so my question is, can we rewrite this into power format using our U sub? Notice that if I want to change the exponent power, the whole group comes up. Oh, okay. I'm going to highlight it. Can I use my chain rule? Yes. Okay. the derivative is. Outside, drop the power, subtract 1. Copy. Derivative of the piece you copied. Okay, rewrite it. Now, as you rewrite it, look at these outside monomial terms. They are going to stay in the numerator, and the only thing that's moving is the grouping parentheses with the power. Oh, can you do the quotient rule? Sure. Should you try looking for the chain rule? Yes. Okay, let's do another one of these, but this time I'm only going to do it the chain rule way. Okay, negative 6 over the cube root of x squared plus 4x. Okay, let's check our chart. Can I simplify this? Not really. Can I rewrite this into power format? Yes, I can. I see a radical, and so I should start by converting, notice the parentheses, because all of this is under the radical, power root. Okay, so I put it in power format. Now, what do I have? I think I have a quotient rule, except that the top derivative equals 0, which means that it's not really a quotient rule, which means there should be a quicker, more succinct way to do this. And so I'm thinking, okay, is my U sub going to work? Why? I think it will. Let's see if we can't highlight the portion that we're going to consider to be the inside. All right, we're going to move this piece up with a negative exponent. And now it looks like the problems that we've been doing. Okay. Can we do the derivative? Yes. Okay. Outside derivative, subtract 1. There it is. Drop the power, subtract 1. Copy. Derivative of the thing you copied in parentheses, because I want you to force me to know that I am multiplying by both 2x and plus 4. And let's put some of this together. Okay, the only piece that's moving is the highlighted portion is going to move to the denominator. These other two pieces, they're just staying in the numerator. And I know that I'm going to have a fraction, so I'm going to move this down first. Okay, and then I'm going to multiply these things. This gives me a positive 2, and I'm just going to leave that here. And I'm not actually going to distribute, guys. I'm going to leave it like that. Now, do you need to write this in power root? Sure, you could do that. But I'm not going to simplify the radical. Power root, the cube root is the only thing moving. That's sufficient. Beautiful. Okay, notice that I didn't need to use the quotient rule because the derivative of the top was 0, which means when I tried to rewrite this, it worked out very nice. Okay, let's do a 5th example. Y equals x 2x plus 1 times what? 4x squared plus 3. Wait for it. E to the 4th power. So let's take a look at example 5, where I am checking my chart here. Okay. I think I have a product rule, and as I look at this, can I simplify? I believe that a 4th power is too tedious to simplify, so I'm going to say no. Can I rewrite this into power format? So let's look at it. This part is in power format, nothing to do. This part, okay, think about it, is power format, and if I see the U sub, then I see the chain rule. Okay, and I'm going to highlight what I think is this. Now notice that not everything is highlighted, okay? And so I'm going to underline here first and second. Notice that the portion that was highlighted as the inside is only part of the second piece. So I'm going to say first, derivative first. Okay, the first is 2x plus 1. The derivative is 2. Second, second is, jumping ahead of myself. Okay, second is 4x squared plus 3 with the 4th power. Derivative of the second. Okay, this is the part where, right, the product rule is just filling in pieces. The first times the derivative of the second, I'm using room, plus the second derivative of the first. That's all the product rule is. It's just copying the pieces and then putting the corresponding derivatives in the right place. Okay, that leaves us with the derivative of the second. And if I block out all these other things that I'm looking at here, how do I do the derivative of this? It's just like those problems that we started with. Okay, I'm going to identify the inside part. Outside derivative. Copy. Times the derivative of the thing I copied. Woo! All right, let's uncover it. Now, there's kind of a lot of pieces here, right? And so what I would like to do is, look here. 4 and 8x is actually 32x. That's it, guys. I know it looks kind of crazy, but this is it. And the only thing we're going to do is try to get rid of these extra grouping symbols, okay? So let's look here. 32, because there's no parentheses, then I'm going to put the 2x plus 1, and then I'm going to put this part here. I'm not multiplying this out. I'm going to leave it just like this. That's a times. Okay, plus, I'm going to put the coefficient in front. And there is a little bit more work you could do, but I'm going to leave it just like this. Wowzers. Okay. let's do another problem. All right. Y equals 4x parentheses 5 minus 3x to the fourth to the fifth power. All right, let's check. Can I simplify this? A fifth power? No, I don't want to multiply that. Is it in power format? Yeah, there's no radicals and there's no reciprocals. Okay. I think I see a product because I have a first and a second. Notice that there are two things multiplied together. So I'm going to split them apart. First, derivative first. Second. Okay, this is the first piece times the second piece. When you get to doing the derivative of the second, that's where you get the chain rule. So I'm going to highlight my inside piece and then do the chain rule. Drop the power, subtract 1, copy, derivative of the thing I copied. Squeaker. Minus 12x cubed. And I'm going to take one step here and I'm going to combine these outside two pieces to negative 60x cubed 5 minus 3x to the fourth. Okay. Then I'm going to fill out my product rule. Okay, first derivative second plus second derivative first. And the only simplifying I'm going to do here is rearranging the grouping symbols and trying not to have extra grouping symbols. So I'm going to leave these parenthesis parts alone. Oh, I forgot a power. This should be a fourth power. Okay. Is that negative 240x to the fourth, 5 minus 3x to the fourth, okay, and then plus 4, 5 minus 3x to the fourth, okay. That's where we're going to leave our answer. Notice that when I'm looking for which rule I'm supposed to be using here, okay, check out our little chart. It is a product. And when I look to do the derivative of each piece, the first or the second, that's when this part comes in, okay? Y equals parentheses x plus 3 times 4x squared plus 1. Whoop. Let me shrink these up a little bit, make it obvious. Okay. There we go. 4x plus 1 cubed. Okay. I need to look at this. When I'm looking at this problem here, I see the part that I don't want to simplify as this fifth power. And try to look kind of closely. See where this extra power is? Try to highlight everything that is inside that power. Oh. And I have a suggestion. Let's look at our chart here. Can we simplify anything? Do we need to write anything into power format? I think I can simplify that yellow part by foiling. First, inner, outer, last. And there's no like terms. Okay, so it appears to be that after I did my simplifying, that my power format is going to be using the U sub. Oh, okay, y prime equals outside derivative. Drop that power, subtract 1. Copy. Times the derivative of the thing. You copied. That's it. Do nothing. There is no other simplification. Scoop that up. There you go. Whoop, backwards one. All right. Notice that I could have seen this chain first and then had a product, but I was able to simplify. Okay, let's look at 8. Y equals, ooh, big parentheses. Over. And negative 2. Wow. Okay, sure, let's do it. All right. Let's look. Can I simplify this? No, there's no factoring or dividing here. Is it in power format? Well, let's look at our different pieces here. X plus 4, yes. X squared plus 8, yes. Negative 2, yes. What rules do you see? I'm going to highlight what appears to be the quotient rule. But I see this outside power. So that means that I have a chain rule. And I'm going to rewrite this one with the U sub here, okay? Because we have, okay, the first one is U to the negative 2. Look at that. When I rewrite that yellow highlighted portion as the U, I get just the power rule. And then when I do this, I get just the quotient rule. And so this is what I'm going to go with. Bottom derivative top minus top derivative bottom all over bottom squared. Okay, let's do a little bit of combining like terms. X squared plus 8 minus 2x squared minus 8x. Okay, so I'm just going to write this over here. So u prime equals minus x squared minus 8x plus 8 all over x squared plus 8 squared. Okay, what's my f prime? Negative 2 subtract 1. Okay, how do I do my derivative? Y prime equals. Now, I have the pieces separated here so that you can see it, but I'm going to try to write it together. Outside derivative, copy, times the inside derivative. Okay, there's the outside. That's why I like to highlight. Helps me position. Times the inside derivative. Now, would I do this work off to the side? I most certainly would. Now, how do I get rid of these extra grouping symbols? The first thing I'm going to do is take that negative exponent. And what happens is it actually just creates a reciprocal with the fraction. All right? And because those big grouping symbols are kind of tricky to look at, I'm going to write it like this. Cubed. Cubed. Notice that the exponent turned positive and it switched, right? Flipped, top, bottom, bottom, top. Okay, times. I'm just separating the numerator and denominator parentheses. And you might be awesome enough to notice that these two things are going to cancel. And we have our final answer of right, really small, Mrs. T. Make it fit. You can do it. Ooh, that's a +8 over there. I don't know why it's hard to see. Over just x plus 4. Wowzers. Give your brains a round of applause. We're going to do that one more time. Y equals big ol' grouping symbols. 3x squared over x plus 1 to the 4th power. Okay. Because you have this outside power, that's what's giving you the chain rule. And as I think about all these things we've learned, I need to look at, can I simplify it? No, there's no division that I can simplify. Is everything that you see in power format? Yes. If you can see the U sub that creates the chain rule, then you have the chain rule. So I'm going to highlight what appears to be the inside. And notice, okay, F equals U to the 4th, and U equals 3x squared, x plus 1. And I rewrote this so that you can see the substitution. Notice that this is the power, this is the quotient. The derivative of the inside is where the quotient rule happens. So I'm going to do it like this. Y prime equals outside derivative. Sometimes rewriting this is all I need in order to be able to put it together. Copy times the derivative of the inside. Okay. Bottom, derivative of the bottom. Top, derivative of the top. Okay, bottom, derivative of the top minus the top, derivative of the bottom, all over the bottom, squared. Okay. Let's simplify. Now this first piece here, notice that I am going to separate the numerator and denominator power because I think it's easier in order to put these fractions together. All right, 6x squared plus 6x minus 3x squared. All right, look at what we have on the top. Just 3x squared plus 6x over x plus 1 squared. Okay, I'm just going to turn this into one fraction. 9x squared cubed a 3 power and a 2 power makes a 5 power. You should feel super smart. Nice work. All right, I'm just gonna put an example up here now. It's kind of similar to what we just saw there. It almost doesn't matter what goes inside these parentheses. It's the inside and the outside. And so I'm checking my chart. Can I simplify this? I could square it. I could actually do the multiplication, but I'm going to choose to do it the chain rule way because it's kind of weird to me to multiply with that fraction. Can I rewrite into power format? Yes, I see a reciprocal, so I'm going to rewrite into power format. Okay. And I do see this inside portion. So I believe I've got we call this the chain rule first. That's what I see. Okay. The derivative is outside derivative, subtract 1, times the derivative of the thing I copied. All right, I can do this. 0 plus negative 1x negative 2. Okay, that's the rule. Now I need to try to simplify some of these grouping symbols. And as I do this, I'm going to put back those negative exponents. And I could leave it like this, but I actually think I'm going to put together this 2 here and this one here. Could I distribute this? Yeah, but this is correct enough. That's good. All right. All right. The last thing we're going to do is I'm going to just briefly recap the examples that we did today. Now that you've seen a couple more, and we're going to talk about how it fits with our little flow chart here. Okay. And I'm going to show you. All right, so here is my example. And this is one where I would say that I did, oh, it's not letting me write. Okay. Okay, sorry for the delay. So here we're going to look at the flow chart up here on the top right and how I decide what rules I'm using. Okay, and here first I am doing, right, chain rule. That is what I'm doing first, right, because this is the first, the U sub, that's the first thing that happens. Chain rule. Okay, so let's look at the second problem. What rules did I use? First, I did the chain rule. Notice that the two black boxes, those aren't rules, okay? Those are just different ways to rewrite the problem. Okay, now let's look at the third example. Right, because when it starts getting interesting, that is where you have to start deciding, what did you do first? Here we go. On this problem, I did the quotient rule first. See that? I picked out the top and the bottom first. Second, I did the chain rule. Because I saw a quotient and the bottom is where the chain rule happened, that was the second thing. It was secondary. All right, let's scooch this up. Okay, here, because of the way I rewrote it, the first thing I'm doing is chain rule. Okay, let's look at the, okay, when I am rewriting this using the two black boxes, that doesn't count, okay? The first rule I see is chain rule. That's what I see. I'm doing the chain rule. That's the only rule I use, and obviously the power. Okay, now what? Let's look down. Example 5. Oh, the first thing I see is a product. See that? That's the first thing I did, is I separated it into a product. Then, the second thing was the chain, because that was within the product rule that I needed to use the chain rule. All right, almost there. It's tricky when you have to decide what goes first, what goes second. Okay. Again, the first thing I do is the product rule. The second thing I did was the chain rule. Okay, here, the first thing I did was chain rule. Okay, look at what I set up first. I set up the U sub first. That means the first thing I did was chain. Drop the power, subtract 1. The second thing I did, okay, the second thing I did was when I was looking at this part of, that's where I did the quotient rule. Okay, what did we do first? What did we do second? The first thing I did was chain, because I looked at the U substitution in terms of separating it. The second thing I did was chain rule. Oh, sorry. Ha ha ha. Quotient rule. All right, last but not least, the first thing I did was chain rule, and the second thing I did right there was just power, just regular derivative. Yes. Okay, guys. Hopefully, your takeaway from today's lesson is being able to identify using chain rule, identify when to use chain rule, whether it goes first or second, okay? How to separate the functions in order to use the chain rule. And to be able to use multiple derivative rules successfully. Okay, so we've got, I like to put chain and power together. Those are two of our basic rules. And then we have product quotient. And somewhere here in the middle, which aren't so basic, but they're related to power, is reciprocal, and radicals. Okay, good luck. Make sure you focus on being able to explain what you are doing when you find the derivatives.